Good morning, everyone. Let's slowly start. Right, my name is Michail, and today we are going to talk about how do we evolve language defaults in Kotlin, and we'll also take a brief look at other languages. What can they do there? And to start, I would love to show these examples of code. And if you open the Kotlin repository and find the very first commit in it, then you'll find out that it was made by Andrei Breslov, the original author of Kotlin. And this commit includes design sketches of a language that will later become Kotlin. And you can see that it still has stronger influence of Scala with pattern matching on the left. We have influence of C# with syntax for properties on the right. And this language also doesn't have nullable types yet, because we are assigning nulls to things that calls like item. And yet, it resembles Kotlin with fun keyword, with override modifier, with types on the right-hand side of declarations. And this is something that excites me, just to see how languages changes over time, how they adopt maybe the same features like in different languages, but because of their philosophy, their constraints, they became quite different and unique. And it takes quite a while to reach from design sketch to reach like a stable language. And in our case, in Kotlin, it took the team about 6 years. And of course, it's not about the language, it's also about like building some tooling, debuggers, IDEs, Docker, documentation, like websites, all that stuff. But in many cases, it takes so long because we want to figure out what are the right defaults in this language, because this is something that is quite hard to change. And it's often also the case that if you, in the end, decides that this default is wrong, then maybe it makes sense sometimes to create a new language. And I think it's also nicely put about defaults and, in general, the system design in this book called Designing Data-Intensive Applications. And while it's about data-intensive applications, it's also like a really nice book for system design. And in the beginning, there is like a section about like human errors. And it says that you have to design systems in a way that minimizes opportunities for error and make it easy to do the right thing and discourage the wrong thing. And the same thing applies for a language. So a good example here is that nullable, non-nullable types. If your type is non-nullable, then the compiler won't stand in your way and just will allow you to call methods to dereference it and so on. And if it's nullable, then yeah, it will ask you to make some checks, and only then you can do some invocation of methods. However, we also know that if interfaces are too restrictive, people will definitely work around them, because sometimes benefits might not worth restrictions, and this is quite a tricky balance to get it right. And one of the examples here is that you can imagine like checked exceptions in Java in some places, that if you invoke a method that throws in a lambda, then you definitely have to wrap it in a try-catch. And because you are like forced and you can't really do something about this, maybe sometimes you will forget to write anything in the catch clause, like to throw the exception, to log it, and then it will be suddenly swallowed, which is like a bad thing. And if you take at other languages, then yeah, for Go, Rust, Swift, it takes like quite some time to get from early access to stable release. So it's like about 5 years, 9 years. Like TypeScript is outstanding here with like 1 to 2 years. For Zeek, like it's still in beta. And, well, they're thinking that if they enable concurrency programming in the language, they might graduate it to stable, and so on. So, and it's actually really, really about the defaults. And to showcase it to you on a more specific example, let's take a look at this quite a simple piece of Kotlin code. We have a class user, just an extension function. We create a bunch of users and do some filtering, maps, and so on. And that's how we intended that people will write most of their programs, right? And to show you like where like these defaults are hiding, we can add, of course, visibility to our functions, like this public or private. we can add the return type for the function is adult. We can specify types for our properties, for our variables. We can use full form and provide arguments in a named form. We can specify full form for lambda syntax to avoid this implicit it. And of course, last but not least, we can also specify modality of classes. And even in these small examples, we can see like a bunch of trade-offs that we have to take. It's like whether every declaration should be public or private or internal by default. Where are the type inference bounds? Like, should we infer types only for local variables or also for declarations, properties, and like functions? Whether every class should be final or open by default, whether everything should be mutable or final. What about this implicit or explicit lambda parameter it? Because on the one hand, it's handy. On the other, like, it can be quite hard to understand when you have like lots of functions in your scope. Like whether named arguments should be by default or not, like properties with getters or just fields, nullability, and whether collection should be read-only or immutable, and many, many more questions. And of course, sometimes like they are changing over time. Like we see that people get consensus finally on non-nullable types now that we are moving to the immutable era. And in Kotlin, we also have like a bunch of new defaults that we want to land in Kotlin someday, such as name-based destructuring, value classes, maybe instead of data classes, companion blocks instead of companion objects, must-use return values, locality, and so on. And some of these features, they are intend to change the meaning of existing programs, and some of the features introduce just a new syntax. And in general, when we introduce a new language feature, it actually changes some defaults, because normally when a new feature is introduced, it's intended to be used in certain patterns. It's intended to replace certain patterns, improve them, because if it doesn't do that, then we just have now one more way to do the same thing, and it's not a good thing. So when we introduce a new language feature, it changes some defaults, even if it's not changing the meaning of your programs. And the question is, like, how can we roll out these features? And I will try to show you what can we do as language designers, as tooling vendors, to help to migrate to these new features. And I would love to start with this example. It might be not the easiest one, but I'll try my best to explain it. So here we have a function for each index. What happens is that we have a lambda, it's just a function that takes index and parameter. And we have int array, and we simply iterate through this array and invoke this function on every element. And it can be useful because we then can try to use it to find index of the maximum element in an array. So the same, we just iterate through an array. We remember what is the maximum index of the current state, save it to max I, and that's it. However, if you try to run this program on Kotlin 1.9 on earlier, then there will be an error, because this max I wasn't smart-casted to int. It's still nullable, which means that we cannot use it to retrieve the element of an array, while we checked it for smart-casted earlier in this if statement. And the reason is that when we invoke this action, this lambda, the compiler really doesn't know anything about the execution of this call, because it might happen anytime. We might save it in a global variable, store it somewhere, and invoke somewhat later. And because in that lambda we capture this max I, we also can change it sometime. So the compiler, even if we checked, might be change max I right after this check, and it will be still nullable. So compiler is just treating it, becomes like very safe, and like, yeah, I cannot smart-cast it, it still might be nullable, so please do something about this. But again, however, and that's the problem of these defaults, that some things you can understand only in hindsight, that actually if you accept a function, then in most cases these functions are executed in place, like in vast majority cases, because we normally do not save them anywhere. We do not store them in global variables to execute them later, because it's like really people don't do that. And yeah, the question, like, yeah, now we understand that, and we'd like to say that, yeah, these functions are in place so that, and the compiler can rely on it and do more smart casts and initialization logic. So can we change the default? Well, not sure about us, but Swift definitely can. Because they used to have the same problem when they released Swift in 1.0. And in Swift 3.0, they had this proposal of making non-escaping closures the default. So they call closures lambdas more or less the same. And on the impact section, yeah, they said that, yeah, of course, that some code like, have to migrate, because like, if you store some variables, like, please mark it as escaping lambda and call it a day. So they just changed the default. They probably break some code, but Swift was still quite young, and probably it was the right choice. In Kotlin, we took like a slightly longer route, but we also arrived there, because in our cases, we decided to use contracts and be very explicit about this stuff. So we introduced this contract section, which can tell the compiler that this action, this lambda, is going to be called in place, so in this exact function. And also, we can provide information about the invocation kind, like whether it's invoked only once, like multiple times, or we just don't know. And it also helps the compiler to do some more analysis. So yeah, and however, also, we have inline functions. And surprisingly, inline functions, they capture the right defaults. And because they are inline at the call side, then we cannot store anywhere this lambda. And what we did in 2.0 is that we said that, yeah, so this contract block and inline functions are basically the same. So for inline functions, we changed this default in 2.0, and we start treating all lambdas of inline functions like as non-escaping, which fixed the example. And now if you try to run the same code and like starting with 2.0, then it will be green, and it's nice. But still, we have this problem for non-aligned functions, and you have to specify contracts if you want to have non-escaping lambdas. So we are very careful, and yeah, one of the questions like, do we change any defaults in Kotlin? And actually, there will be one precedent in Kotlin 2.4. We have this situation when we have a class person. We have, like, for instance, two mutable properties, and have some annotations that check when we change these properties that this string should be not blank, or this integer should be positive or 0. And one of the problems is that, of course, as I showed, we hide quite some defaults. And the question is, like, where do these annotations apply? Are they applied to constructor parameters? Are they applied to properties? Are they applied to fields? Or are they applied to everything at once? Yeah, and like before Kotlin 1.0, we had to choose something. And we decided, yeah, they are applied just to value parameter only, so to the parameters of the constructor. That is our default. That is OK. Unfortunately, it's not OK for some annotation processors, because what happens? When I initialize this person using the constructor, then annotation processor will check, yeah, that this string is not null, for instance. However, when I then change this variable just not through the constructor, but just through a regular setter, then I will miss some checks. And yeah, the annotation processor won't work correctly in some cases. So what we actually want is to say that, yeah, it's also applied to fields, so that every change of these fields will be checked properly by annotation processor. And it's a breaking change. It might be not the largest one, but again, some annotation processors already lived for us with many years, and they relied on the existing behavior. They know how to deal with that, and now we are changing that. So we started to be very careful, and starting with Kotlin 1.1, 2.1.20, you could see this warning that please migrate to this full form syntax, specify what you want actually to apply it only to value parameter, to everything all at once, or we can just enable compiler argument that will use the new rules. And in 2.4, the default will be changed. So these annotations will be applied to more places, making sure that the annotation processors check more places. So, and we decided to break this thing because, in our opinion, it brings more safety to programs, and it's worth it. And again, it's mostly on the shoulders of KSP authors, and there are not that many people compared to developers, and we can work with them and migrate them to these new rules. Good. So next examples are mostly about nullability, because it is good that now we have consensus in the development, that if you develop a language in the 21st century, you have to have non-nullable types. And if you don't have, you have to think hard how to migrate to non-nullable types. And there are good examples in industry, and we'll take a look at some of them. So with Kotlin, it was easy, because originally there were no nullable types, and they were added somewhere before Kotlin became stable. So good. It's a nice way to do that. Dart. Dart was released with nullable types by default. And while it looked like Java, it's actually Dart. Don't get mistaken. And you could just invoke a length method and pass null to it. And then you'll get the null pointer exception, because everything was nullable by default. However, starting with 2.12, if you opt into a new nullability feature, the compiler will start treating types as non-nullable. And they also introduce syntax, unsound nullability, mixed nullability. But the general pipeline was the following. First, you're announcing the feature. So because you want to check that it actually works. There are no fundamental things that blocks the feature from making this beta and then making this stable. Then they started to migrate their core Flutter framework and the most popular packages for Flutter. And then they had introduced this as beta, and then they introduced it as stable so that applications can also start migrating to sound nullability. So it's typically this way, that first you introduce the feature, check that it works, syntax works, there are no blockers. You start with your main libraries, frameworks. Then you embrace the community to start migrating your libraries to this new feature. And only then you start migration of applications. And at some point you change the default. And it's a good example because if you take a look at our features and other features, they actually follow more or less the same path. And now let's take a look at this example. So here we take a list of 3 elements. We try to add 4 to it, and then we print numbers. So who knows? Is there any problem in this code? Yes, there's a problem. OK. Actually, yes. The problem is that we'll print 1, 2, 3. And the thing is that we just forget about this 4. And the reason is that list creates a read-only collection. And we do not want to modify it when we add new elements. And we don't know what happened. Maybe you forgot to use these numbers plus 4. You wanted to use it for something else. Or you wanted to create a mutable collection. But what we know for sure is that this result is just ignored. And it's better to either remove it completely or maybe do more significant changes to your program. And to fix that, we want to introduce must-use return values, or as others might think, we want to steal another feature from Swift. But it is what it is. And the thing is that we have the same pipeline. So we introduced the feature flag in Kotlin 2.3. It has 3 states, like check, full, and disable, which is the default today. And in 2.4, the core libraries, like Kotlin X libraries and standard library, are compiled in this full mode, which means that now every function that returns something, it's actually, if you call it, you have to check its result, with some exceptions that you can mark your function as ignorable result or so. And we are aiming to enable now this check mode by default in Kotlin 2.5, so that you get warnings when you invoke functions like add, you create, like invoke constructors, and so on. But mostly it's going to be like you'll get warnings only for functions from standard library and Kotlin X libraries. And like as Dart embraced the community to migrate your libraries, I embrace you to try this feature and migrate to must use return values as well, because it's actually a nice default. And it's also like if you develop a language and you want to have some clear separation of functions that have side effects and that are pure, I think that's the right default, because basically if you invoke a function that is pure, that just does some computation, and you don't use its result, then it's a bug. That's what it's 100% a bug. But if it has like a side effect, then you can mark it specially, and probably these functions are the minority in your code application. Yeah, and at some point we'll see like by the feedback how it goes. At some point we'll enable the full mode for all application code, but we don't know the release date so far. Good. So in Dart, they gradually switched to non-nullable types. So what happens in C#? In C#, the story is slightly different. Like the ecosystem is older. They have like many more lines of code. They have frameworks and so on. So there's actually no global switch in the language. However, if you create a new C# project today and try to do some nullability stuff, like dereferencing nullable types, then the compiler will emit warnings. And the thing is that when you create a new project, they will implicitly edit this line that nullable is enabled in your project, which means that, yeah, we now start treating regular types as non-nullable types, and for nullability, you have to use question mark, same as in Kotlin. And this is quite interesting because it's a safer way to enable new features, but in Tulip. We did not change the language because your code, as it was written in some version of the compiler, will be still the same if you upgrade the compiler and don't enable this feature flag. It will only change if you start changing it with the feature flags. And this is examples of such features. We can find many, many more. For instance, I talked before about this changing defaulting rules for annotations, that, yeah, we are going to change it in 2.4. But actually, if you try to create a new Kotlin project using Spring Initializer, then implicitly you're already using this feature, because this initializer adds this free compiler argument that -x annotation default target is param property. So it's actually already implicitly changes how your program behaves. And we have more examples. And one of the examples is about enum values. So who knows what is the problem of values? It's the same as in Java, in Kotlin, it's the same call. What is the problem of values? Who knows? Good. And that's actually very good, because most likely you already use new feature in Kotlin but don't know about this, and you don't have problems. So the problem is that it was designed many years ago, and it was decided that values returns an array. And the arrays, they are mutable by default. You can change elements in it. And you can imagine that if you return a mutable array of enum entries that you can change anywhere, that's not a good thing, because it's returns an array of entries, you can just assign a new element, and everything will break. So it was decided, yeah, we are not going to change this API, but instead we'll just create a new copy every time. So if it happens so that your .values call is on some hot path in a cycle, then you are going to create new arrays every time, because we want to be safe. And what we did in Kotlin is that we actually, in Kotlin 1.9, we introduced this feature called entries, and simply replaced it with a new call. But now it returns not an array, but immutable list of entries. So we actually don't recreate array every time. It's better API because we normally work with lists. Yeah, and it's better in terms of performance. But again, values, if you check how many times people call values, then it's going to be like a very big number. And we do not want to say that, hey, that's deprecated, rewrite, please, like almost like every single program that you have in Kotlin. That is going to be too much. So we tried to do this migration in tooling. So what happened is that first we deprioritized values in auto-completion in IDE, so you have to work hard to find it. We emitted a soft warning in IDE with a quick fix to replace it to entries. Like if you invoke Java to Kotlin transformer that has value calls, then it will implicitly change them to entries. And also all our Kotlin guidelines and documentation use just entries. There is no like values at all. And it's nice because we introduced a new feature, we improved like performance and the API in Kotlin, and we didn't spend any time on teaching people because like it's you'll automatically do this and use this new feature. And sometimes we want to be even more delicate. Like if there is like a good example of a range until operator. So we have this pattern in Kotlin. When we have just a for loop, we iterate from 0 until length. And yeah, the question, is this range exclusive or inclusive? Like maybe, maybe not. But we want to know for sure that we also like ask people, and they're also not sure. Our developers are not sure. And we also know that off-by-one mistakes are very, very popular. It's one of the most popular like mistakes in programming. So we decided that yeah, until is not probably was the good choice. So let's introduce a new feature that will just explicitly tell that in the syntax that this range is exclusive. So, and use this less operator after dot dot. But again, most of programs, they are fine. They were using until. There are like many of them. Again, we don't want to like emit like compiler warning because most likely your program are okay. And the same even now goes for ID inspection. Probably they're fine. We just don't like want to bother people with rewriting your code because we want you to focus like on your codes and not really on Kotlin as the language. So what we decided is that we want to make this thing as in C#. So if you create actually a new project using IntelliJ IDEA, then we'll put some information in .idea folder that, yeah, this is actually a new project. It has this new feature. And only in this progress, we enable this inspection about that until can be replaced with dot dot less operator. And this way, yeah, we'll get like all the new code. We'll get this new feature. It will get better readability. For people who like really like follow the language and would love to like use all the new features, you can of course enable this inspection in your existing Kotlin project and migrate it. But in general, we try not to bother people with all new additions that we do. And the main thing is that for tooling and the compiler, it's really hard to identify newly added code because what we want to do is that, yeah, so now we introduce this feature and all new code that is added to your program, to existing projects, to a new project, should be used this new feature. And one way to do that is, yeah, let's introduce a warning. But then if you compile a program, then all the existing programs will get this program. And we don't want this because, again, there will be plenty of warnings. And what happens in practice is that people won't read warnings at some point anymore. And the same goes for tooling. If you introduce and start a new feature, the tooling can like highlight everything in yellow. And again, that is something that we do not want. We would love to like highlight parts that only were newly added. So this way we could gradually teach people about this new feature. And only then they can decide whether they want to rewrite their entire code base or not. And this is where I think that AI tooling might be exciting at some point, because with AI, what happens today? First, we write some code, so people write code as they know, as they're used, and only then we emit like a warning and inspection. In ideal situation, we would love to write the code from immediately in the right way, so that we even won't have to emit any warnings or inspections. And here, I think that that's why, for instance, this AI tool might help us, because I'm quite positive that it can accelerate adopting of new language features and accelerate languages, because sometimes instead of teaching all the developers, like all the Kotlin developers, new developers, we may teach just a few agents and maybe through some tooling, prompts today, skills. And now that, for instance, imagine that you're upgrading your project to Kotlin 2.4, you use, of course, Ampere, Kotlin toolchain, and it comes along with newly added skills about new language features that agents will use. And of course, you can use them as well, but agents will automatically use these skills and know about new language features and know how to use them, in which patterns, and so on. And then when you generate the code, then it will automatically generate it with new patterns and new language features, like improving readability, safety, or performance. And which means that maybe the cost of adding incremental updates to language will maybe come lower, and things like range until operator or enum entries can land faster in the language. And this is something that is in progress today, that we are preparing this, you can find this Kotlin agent skills repository with general skills, for Android development, for Compose, and we are also preparing for language features. So if you're on Kotlin 2.3 or Kotlin 0.4, even EAP version, and would love to have it a try, you can try to download these AA skills, and they will include everything about explicit backend fields, context parameters, companion blocks, almost everything. And surprisingly, agents understand it quite well. Of course, we don't have the main thing here is evals, so that we haven't released it yet. But once we check it more thoroughly, I hope that we'll do that. And actually, that's it from my side today. And I think that we have some question. If it's time for questions, and if you have some, please. I enjoy you to start the discussion. Thank you. Okay. There are microphones that you can use if you want to ask anything.
Thanks for the talk. I will come back on the presentation that you did last year, and you introduced the rich error. I didn't see it released the recent releases.
Yeah.
Or talk about the 2.4. So do you know any update about that?
Right. So about rich errors, we just yesterday released a new keep with the updated design. So it's in development, so feel free to open our keep repository and see about this updated design. So it's still in progress, and I hope that we'll start prototyping it soon, but we'll see, because we found some trade-offs, but still the feature is still in our pipeline, and the update is right there.
Yeah, thank you, because I think a lot of developers are expecting it on me first. Also, thank you for the must-use return values. This is also quite expected.
Sorry, could you repeat, because I didn't really hear the...
Yes, I wanted to also thanks for the must-use return values. This was also presented last year and has been introduced quite recently.
Which feature?
The must-use
return values.
Yes.
Yeah. So the plan is to enable it by default in Kotlin 2.5. So right now you can use it, enable it via compiler flag, and you'll get warnings from standard library and Kotlin X libraries, and it will be automatically enabled in the next release.
Yes. Thank you.
Hi, thank you for the talk, first of all. I have one question about these optional flags which are included over Spring Initializer, for example. You said they are included in the .idea folder. Doesn't it introduce some inconsistency if you're building the same project from CI, CLI, if you migrate it to a monorepo as a module?
Yep.
So you would have different warnings.
Yeah, so what we learned so far is that it can introduce inconsistencies if it affects your ABI. So for instance, if you have like a declaration and this feature changes like how it presents in the bytecode, what is its meaning. Like the best example again is these nullable, non-nullable types. Because if you just consume a library which is like has this feature flag and the other doesn't, and they look the same, then it's definitely going to be inconsistent because something will happen on intersection of these types when you inherit from like different libraries, then it's definitely a problem. And in C#, it's actually a problem today with this. But if it's mostly about bodies, about annotations, then it seems to be way better. And this is where we can like change defaults more aggressively.
Okay, thank you.
Hi, thanks for the talk. So language design, like all design, is essentially about helping people making the right thing, right? And the right thing is defined as whatever we see as the vision for the language. Right? And this vision evolves with time. And you showed all the different ways in which we can make it more concrete. How do we evolve the language, right? But have you ever had a time when we actually change your mind about what is the right direction and you had to make like a U-turn in the language design, into the philosophy itself?
Yeah, actually, it's we change our minds like quite often. Like otherwise, we will just wouldn't have this keep repository with discussions, internal discussions. And I think one of the recent examples of this was about this named only parameters. So we wanted to introduce a modifier that tells us this parameter should be passed only in named form. So we introduced this keep. It was very flexible in terms of where you can put this modifier. And yeah, in the discussion with the community, we understand that it's probably too much. It will cause like a lot of bike shading, like unnecessary pull requests. What happens if I want to change my mind back? So we decided to not to introduce this feature right now, but go back to the like whiteboard and think what is the better default there. Maybe a better default is like when you have like a function with 5 parameters or more, then they all should be passed in named form. For instance, that might be a more reasonable way. It's way simpler at least, and you don't have to think like where I should put my named only modifier. Like, is it like fine for this function or for that function? Or maybe if you have many parameters, then it should be invoked in the form of a builder. Like, we don't know, but yeah, that's one of the examples. And there are like many more examples that are like where we that we change internally that do not reach the community discussion.
Does it happen often that you do change your mind after it was released? After it was released? Yeah.
Well, like at least starting with Kotlin 1.0, I think no. Like I don't remember such features that we released, and yeah, we want to take it back immediately. Yeah. I don't know. There are like features that I would love to take back from Kotlin 1.0, but of course it was hard to understand because like sometimes you just need hands-on experience to understand that this default is not the right one. But now we have way more data, we have more developers, and it's slightly easier for us to understand whether the feature fits the language or not.
Right, thanks.
Hello. What's the spark for introducing new defaults or new features? Are you just checking other languages, or you have some quarterly meeting when you are discussing possible features or defaults? Again, what's your process?
What's our process? So the process is typically the following. First, we are collecting pain points, use cases, like feature requests. when it's a feature request, we're trying to understand why people want this. Like, does it create like some friction in the language, or it's just like it's a common way to program something, or it just causes some bugs. Then we think that like, okay, what can be done to improve this? And the first step is actually, can it be improved in the tooling side? Because it's way easier to change tooling, maybe with some inspection, maybe with some formatting, maybe with some linter. Then we see that if it's quite critical, or it's just, yeah, it should be applied for almost any project, like with this .entries thing, then yeah, it should be a language feature. And then we discuss it internally. We create a KEEP, publish it, wait for some time, trying to get some feedback from the community, and then start prototyping it. Then we release it as experimental, and again, check the feedback, and only then we decide whether we want to stabilize it or not. So it takes quite some time, I would say. Sometimes it's like, at least 1 year, but typically to add a language feature, it takes more than 1 year, like it's 2 years or more.
Okay, it sounds like a quite long process. Thank you.
Thanks.
Hi, thanks for the talk. I have a question regarding ABI compatibility. I think it's an ongoing challenge that has never changed, that when you want to rename something in a library, you are not only breaking source compatibility, but also binary compatibility. And I know that something, the protobuf, also known as protocol buffers, is immune to, because you have to define an ID. And I was thinking, would it be possible, maybe in a language like Kotlin, to have a mode where, as a library author, you could specify an ID for a field, just in case you rename it, so you don't break compatibility with already compiled stuff, and only break source compatibility, which could also be alleviated via migration data, AI or not. I think AI is not the best way to do that, but that's another topic. Yeah, what about IDs to help that?
Yeah, good question. For JVM, we have this thing that is called the JVM name. It has some restrictions, but at least it helps you to preserve binary compatibility. So you can actually rename the function, but say that in the bytecode is going like, please preserve the same name. So it will, you won't break binary compatibility. The thing that is missing and that we are investigating today is that whether there should be like a general annotation, like called something like binary signature name, that you can use like in command code, like, and it will basically preserve the name that you specified in this annotation, but the function could be renamed to something else, to like other name that you find better, or just if you want to deprecate it completely, introduce a new function with new parameters, then it could be used with this binary signature name. So that's at least like our vision today. There are like design notes, again, on the KEEP repository about it. So yeah, feel free to provide your feedback there.
Doesn't it look like a band-aid to have a name that is no longer the name that you want to have? Like in protobuf, you don't have a name and the old name, you have an ID, that is the source of truth, and you have the current name. So like instead of having like a general multi-platform name, it could be like multi-platform ID, which technically could be a string, but you don't want to have it be the name. Because I think when you read the code, if you have a JVM name and then a name, it becomes confusing if because you have a story that maybe you don't care about, but when you read the code, you see it. Do you see what it's a subtle thing. It's maybe nitpicking.
Yeah. Right now, we haven't considered that because, like, again, the design is quite flexible, just to understand like how people are going to use it, what they wanted from it. So yeah, whatever name is specified, it will be used. But yeah, we can talk about this in more detail, just to understand better your use case.
I'd be happy to. Thank you.
Thanks for the talk. Quick question, silly one. Typing code is so 2025. Everybody just prompting their agents. So the question is, how does the inception of AI on so many stages of development, going back from the prototyping and way into reviewing and asserting the code, is altering your process of accounting for it and designing the language forwards. One of the things that I noticed, that obviously AI has all the knowledge of the entire human being, but obviously it's often out of date. It doesn't utilize the latest of the language. It is not aware of the function of the language. So I wonder how these alterate the overall equation in this design process, if iterates at all.
Yeah, absolutely. So again, with adding new features and like using latest language features, today it's quite easy to achieve with AI skills that will provide with new Kotlin versions. So it's actually, if you just write like or ask agents to create a skill out of the skip, it will do like a great job, and then all your new code will use this new feature like in places where we recommend and so on. Speaking of how it affects our design, like we are like trying to see like that it's not a new, like absolutely new concept for LLMs, because otherwise it will be hard for them. It's not that implicit, so that, for instance, execution order is important, that the LLM can understand again what's going on. Like silly tests that we are doing sometimes, if you have some syntax, if you just go to LLM and try to explain this piece of Kotlin code, this new syntax that is not existing, and it's a very like silly benchmark, but at least if LLMs cannot explain what's going on, then it's like a red flag. Maybe it also means that for people it will also be unclear, and we have to do more checks. So it affects in these ways. But in general, again, I think that AI is a tool, and in the language development it also can help and can accelerate adding like new features to the language and understand like and actually use them in more projects and right after the release of a new version of Kotlin.
Thank you.